Recorded. So most of the people might already know me. For those who don't, my name is Kashif Mahmood. I am currently working at Marcus Technologies as engineering manager. I have worked on Kotlin multi-platform mobile since last year, building two production apps with Kotlin multi-platform mobile when it was called KMM, and now that KMM is actually uh, dead and it is no longer called KMM, it's KMP and just KMP, whether you target iOS and Android only or you target desktop, web, and other things as well. So, something more about me, I have been featured by Kotlin Official on Twitter for my one of my open source apps, and that was Kotlin News app. And other than that, I have contributed to some Jetpack Compose libraries as well, Kotlin multi-platform libraries. You can see my GitHub for that. So starting with Kotlin multi-platform, so it used to be called KMM. There was a part that was called KMM, and then there was a part called KMP. The mobile part, Android and iOS part used to be called KMM, the Kotlin multi-platform mobile part, but now it's only called KMP. So we will be referring to Kotlin multi-platform only, not to Kotlin multi-platform mobile. So moving on, let's start with a story. So one beautiful morning, you get $1 million app idea. You want to build the app as soon as possible. You don't want to waste time. You want to get ahead of others so you don't lose your idea. But what would you do? Would you start coding as soon as possible just by waking up? Or would you think about a few things and then move on? So, building an app is not an easy task. You have to take a few things in consideration, like your tech stack, and your stakeholders, how the team will interact with the code base, whether you already have Android developers with you who will be working on your app, or you will be hiring different developers. Maybe you have web development experience, not Android. You will then have to adapt to the mobile development technologies as well. So there are a few things that you will be taken in consideration. The first thing that you might go ahead and think is, would you want to go native or would you want to go cross platforms? So, making it a bit clear here, by native we mean pure Android apps built with Java or Kotlin with XML or Jetpack Compose. And similarly for the iOS part, it will be Swift UI, UI Kit with Objective C or Swift. So, in both sides, there are few issues and there are few pros and there are few cons. When you go native, you have to build two teams, two for different platforms, that is for one team for iOS, one team for Android, resulting in double the cost because if you hire cross-platform um, developer, one will be working on both iOS and Android. Just give me a minute. So one developer will be working on both Android and iOS, building in less time, and the team will be small, hence less cost. Similarly, if you go native, you will have to align both iOS and Android teams together with feature modules, whether these are time taken to release a feature. The iOS team usually takes a bit more time than the Android team for building a similar feature. So if you have completed your work on the deadline, but the iOS team hasn't, then the feature will be delayed. But if you go cross-platform, like with Flutter or React Native, one person, one code, one UI, so that won't be a case. Similarly, if you go native, there will be a QA for both Android and iOS, making much more taking much more time to release a particular feature. So these are a few things that when going native you have to take in consideration. This will result in double the effort and double the money spent. Similarly, there are some challenges when you go cross platform as well. For example, let's just take Flutter into consideration here. It will result in a small team, one developer, two platforms working simultaneously, but there is a demo effect. So, what is a demo effect? What you see in a demo of a particular framework, it doesn't mean that the production app will look and feel just like it is in the demo. Whether it will take one, if it is taking one line to do an animation in a demo by Google or some other places, but it will takes much more time when you are building the same thing. Some features might not be available directly to Flutter. For example, Material 3 came to Android native a year or more ago, and it just came to Flutter 3 in I think about 2 to 3 months ago. So if a feature is not available but you want to use it, you will then have to write wrappers, and you will be writing native code anyways. And if you are using some views that are, for example, dialogues in your Flutter app, the iOS user will be naive to that. The iOS user won't know what a dialogue is or how to interact with it. It will feel like an Android app running on Flutter, sorry, on iOS. The second thing, the last thing here, what if the framework that you are using is dying? For example, Apache Cordova or Ionic is not in a good state these days. React Native is also dying. So, for if you have spent 2 or 3 years running a particular framework and you don't know whether what will be its state in next 5 to 6 years, then what will you do? You have spent 3 years practicing a particular framework and it won't exist in next 5 years. So what about your experience and what about the app that you have built with that particular framework? This will then result in more than 2x the effort and resources. So in many cases, when you are building an app using a cross-platform framework, it results in much more uh, it results costing you much more than a native team. So these are a few things that when building an app you will take into consideration. But similarly with these two apps, Android and iOS, what if you want a web app as well? So the things that we talked about in the previous slide will get 3x this time, because now you need to develop a web app with much more complexity and handling three teams at the same time. So this will be a cry time. But here we have Kotlin multi-platform to the rescue. So Kotlin multi-platform that is not a framework unlike Flutter, React Native, or Ionic. It is an SDK that you can use to share code. It is developed in Kotlin. You decide what to share. If you want to share every piece of your business logic, you can do that. If you just want to share a particular piece of code, for example, if you want to share analytics, or if you want to share some enums that contain a particular uh, some sealed classes that represent a particular screen state, or a UI state, or maybe API response states, something like that. So it depends what you want to share. It doesn't force you to share UI. It doesn't force you to share everything that you have developed. For example, there are two teams. One is the iOS team and other is the Android team, and both are working with their existing architectures. If the app is built with Swift UI and the Android app is built with Kotlin, but there there is a difference between analytics. If sometimes the iOS teams forgets to add an event, and sometimes the Android team forgets to add a few things here and there. So to make the analytics scheme consistent, what you can do is you can add a new shared module, and in that shared module only the analytics code r- will exist. For example, some events that will be going on to Firebase Analytics or any other analytics platform. So it doesn't mean that you have to share every bit and every piece of your code. You can share that analytics code and then export it to either Cocoa Ports, XC framework, or any framework that you want to use with the iOS. And similarly, AARs or libraries that can be built with CI/CD. For example, there is a great tool by TouchLab called KMM Bridge, which allows you to build XC framework Swift package manager that it uses. I don't remember the name of it, but you can build both iOS and Android libraries using KMM Bridge, and then you can just integrate it simultaneously with both platforms. And now you have a shared analytics architecture for both your Android and iOS apps. So it is an SDK. You can use it if you want, and if you don't want to use it, it doesn't force you. So it's as simple as that. No platform specific uh, dependencies like other frameworks. And no, for example, Flutter has, if you want to use splash screen API in Flutter, you still have to use some native features. But with Kotlin multi-platform, it's just an SDK that lets you share a piece of your code and nothing more. So UI is developed natively, but not necessarily. So, but prior to this, uh, what we used to do was to use Swift UI on the iOS side, and uh, on Android side, we used to use Compose. So, this is something that depends upon your liking. If you want to use Swift UI and enjoy every freedom that it gives you, then yes, you can use Swift UI. Similarly, if you want to use Compose on Android or XML on Android, you can use that as well. But here's the interesting part. With Kotlin multi-platform, you can plug in any framework of your choice to use. For example, if you want to use React Native with Kotlin multi-platform, you can do that as well. So it's not limited to Swift UI and Compose or Compose multi-platform. You can use Flutter, you can use React Native with it as well. Okay, so moving on, Kotlin multi-platform uh, gives native UI plus shared business logic. So if you go this way and don't share the UI, you can use Kotlin multi-platform on Linux, Windows, Mac OS, all the iOS targets, tvOS, watchOS, similarly JVM, Android, uh, WebAssembly, and it I think it covers everything that a software engineer can target uh, using its app. But there are a few things that we need to think about as well. If you want to use, let me just, okay, if you want to use Kotlin multi-platform with share UI, you have to take care of few things. For example, you have to learn Swift UI for iOS, Swing for or JavaFX for desktop, similarly Compose for Android. So there is a better alternative with multi-platform that you can use. So next part is how do these targets communicate with each other. So there is a very simple way uh, called the expect actual mechanism. So that how does the expect actual mechanism works? Give me a minute. Okay, let's start again. So, how does the expect actual mechanism works? So, there are a few things that Kotlin multi-platform does not support by itself and require platform-specific implementation. Okay. By platform-specific implementation, what I mean is that every platform has its own implementation under the hood, how it handles specific things, just like UUID. So on JVM or Android, we can use a UUID.random UUID.toString just like we do on Android. But on iOS, what it uses NSUUID. So how it calculates the UUID part and with the timestamp and everything is different on iOS and different on Android. And for these parts, we use expect actual mechanism. So when we create an expected class, expect function, or expect object, we can um, create any kind of expected parameter that we want, and then we have to give its actual implementation in every platform that we use. For example, here we have two platforms, Android and iOS. We give its native implementation of UUID to the main function, the common shared part. So in the shared part, we will just call the getUUID string function, and under the hood, it will check which platform we are currently on, and then and then it will call that particular actual function. And in this way, we can use platform specific components and platform specific things in the shared part. So if you are building an app the traditional way with Android on Android, Java, XML, or Compose, and similarly on iOS, you are using Swift UI with Swift, or UI Kit with Swift, or Objective C, or anything. So if you are on Android, you will be using Room for database, and similar core data for iOS, Retrofit for networking, and Lamofire for networking on iOS. Similarly, RxJava activity with views, lazy column in comparison with lazy H stack and lazy V stack, and other. If you are using on web, there are a lot of things that you can use. There you can see from this table that there are a lot of things that you will have to manage just to build three different apps. But with Kotlin multi-platform, all of this comes to just these things. SQLite for uh, database, Cato for networking, serialization for JSON serialization. We are familiar to coroutines and Kotlin.test for writing your unit tests. Similarly, on Android, we will be using activity and lazy column for displaying lists, view, and lazy edge stack on iOS for the same purpose, and other web stuff that I don't know. So all of this comes. Uh, so all of this just comes to this, and you only have to manage these 5 to 6 libraries to build a simple app. No more core data. More for the iOS devs, they can understand me that what a pain core data is, and just SQLite, Cato, serialization, coroutines, and that's all that you need for building three different apps on, actually four different. We don't have desktop listed here, so four different platforms, one database, one networking library, one concurrency library, and that's all you need. Okay, there are some key features of Kotlin multi-platform that we have. Shared code base. We use the same code base on different targets, whether it is desktop, Android, iOS, web, desktop with Mac OS, Linux, and even Windows. Then we have specific implementations, so we can use all the cream from different platforms in our code base. Uh, So the app does not look like an Android app running on iOS, rather than it looks and feels just like any other iOS app. Seamless integration, as we discussed, that it doesn't mean when you are using Kotlin multi-platform, it doesn't mean that you have to share every bits and pieces of your code. You can start small, and eventually you can integrate anything. It supports Cocoa boards, it supports Swift Package Manager, it supports Xe framework. Everything that you want is there. Then coming to performance, since everything is native, you don't have to worry about performance like you are like using like when using Flutter, you have to take performance in consideration, um, when especially with React Native. Flutter has good performance, but when using Flutter, this performance is a bit good as compared to React Native and other frameworks. But when you are using a Kotlin multi-platform, performance is not an issue because it's all native. Shared testing, you can test all your business logic inside the Kotlin shared code. The unit test, everything is there, and you can now even write UI tests for your Compose multi-platform code just in your shared code base. Gradual adoption, again, same thing, and the same thing that you don't have to put everything in the shared code and just rewrite your app. You can start small, and then um, if that fits your needs, then you can gradually adopt the Kotlin multi-platform frame SDK, and you can share all of your code. Create community support. The Kotlin multi-platform community is growing day by day. There are a lot of samples. The Pakistani community, especially, are learning new things in Kotlin multi-platform, sharing builds. Abdul Basit is doing great work. He's very consistent, unlike me. So do check out his repositories as well, and especially the one that is called the recipe app. He has deployed the web app on GitHub pages as well. So it's a great repository, and you can learn a lot of things from that as well. Coming to Compose multi-platform, the Compose multi-platform framework currently supports desktop that includes macOS, Linux, and Windows. Then on it supports Android and iOS and web as well. So those who are familiar with Jetpack Compose and already have built Jetpack Compose apps can just can copy and paste their code for the most cases, and it will seamlessly run with uh, Compose multi-platform framework.
I'm unable to hear. Are the other guys able to hear the sound?
Sorry guys, where did I lost you?
Just at the Jetpack Compose, using Compose UI on different platforms.
Okay, sorry, I went to mute for some reason. Okay, uh, for those who have familiarity with Jetpack Compose, can just copy and paste their code into the shared code with and add the Compose multi-platform plugin to their code, and it will run seamlessly. However, there are a few things that currently don't work with Compose multi-platform. There are a few things like in Canvas, I guess that don't work. Compose multi-platform constraint layout doesn't work. Floor layouts are in 1.5.0 and that are still in RC mode and does not have a stable release yet. Similarly, the new horizontal pager is also in RC. So most of the things are there, not the latest ones, but they are coming to Compose multi-platform. We are trying to build our production app into Compose multi-platform, and we have integrated some platform specific components as well, and it is running seamlessly on iOS at the time. And once is released, I will be sharing its link to the group as well, so you guys can check it out as well. Okay, so it can run on desktop, Android, iOS, and web as well, WebAssembly. And on the desktop side, it can run both on Linux, on Mac OS, and on Windows as well. So if you have an app currently built in Jetpack Compose, you can in no time convert it to an iOS app and a desktop app and a web app as well. Okay, so how it works. There are some iOS APIs like Core Bluetooth Foundation, Core Data, ARKit. These libraries are already available through interop in the shared code when you are using Compose multi-platform. For example, camera, there is a good sample by JetBrains using the camera app. Then, and if you check my Compose Movies app, I have added platform specific video players, YouTube players, web views as well. And similarly, you can use any UI kit view inside your Compose view. If I can just share my screen and show you that as well. Can you guys see my screen?
Yes.
Okay,
Yes.
this is an iOS app built with Compose, and it is using YouTube Player, that is an iOS library being used in the shared code by this app. So the purpose, and if I click on details, it will load a web view that is also a platform specific view, a UI kit web view loaded inside Compose. So the purpose of showing this is that you can use any UI kit view inside your composable, and it will look just like an iOS app running on an iOS device, and an Android app when running on an Android device. So you can use Android views in Compose multi-platform using Android view, and if you are using a UI kit view in your Compose multi-platform app, you can use UI kit view. And for those who are familiar with JavaFX and Swing, you can use Swing panel to use a Swing view uh, inside your Compose app. So everything is interoperable. You can use any UI kit view inside Compose. Similarly, you can use UI Swing views inside Compose and everything. So because of this interop, you can use any new feature. For example, if you want to build something with AR, you can use ARKit, and rest of the app can be in Compose on iOS. Similarly, if you want to build a video player or anything you want is anything that you can imagine can be done with Compose multi-platform with interoperability with UI kit and Swing. Sorry, Swift interoperability is already planned by JetBrains, and it will be coming to Compose multi-platform very soon. You can use any, not any, but UIKit based iOS libraries in your Compose multi-platform through Cocoa Ports Dependency Manager. So the interoperability is great, and I think this is the future of cross multi cross platform development. Speaking of interoperability, this is a picture taken from JetBrains website, and these samples are actually available on GitHub as well. You can see them by yourself as well. So this is a UI kit view, the map view embedded inside a compose screen. Similarly, on the right side, this is a compose view is embedded inside a Swift UI screen. So now you can easily guess how great is the interoperability. So when building a compose multi-platform app, a few things that come to mind are how to share resources, the images, strings, fonts, draw files, and things like that. So there are a few libraries already available for these things. The first one is Mocha resources that we are also using in production in our apps. This is a great library. It lets you use strings, images, and fonts inside your Compose multi-platform app. Similarly, there is a plugin by JetBrains which is Compose Resources. It is actually experimental, but it can help you use drawable. It is great with drawable, with Mocha Resources is not. So most of the times you will be using both Compose Resources and Mocha Resources um, in the same project, but in maybe in the coming months, the Compose Resources will not be experimental anymore, and once it gets stable, Compose Resources might be the way to lead here. The next thing comes from image loading. For image loading, there are few libraries. The first one is TouchLab Image, just like Async Image or Coil or Glide. These libraries help you load images in Compose multi-platform apps. These are Camel, Compose Image Loader. I have tested Compose Image Loader and Camel. These both are great libraries. Camel is a bit more developer friendly as compared to Compose Image Loader, uh, but Compose Image Loader is a bit fast as compared to Camel. So I haven't tested TouchLab Image, but it would be good as it is coming from TouchLab. For navigation, just like Android X navigation, we have several alternatives. The first one is Decompose. Decompose can be used with React Native and Flutter as well. Voyager is for iOS, Android, and desktop. Pre-Compose is also a great library, and iOS-based navigation is also an experimental with Pre-Compose. So if you want that swipe gestures for navigation on iOS, Pre-Compose is the way to go. You can find all these libraries in the link that is KMP Awesome. If you just search on KMP Awesome on Google, you can find it the first link. Okay, Compose multi-platform also supports web through Kotlin and WebAssembly, but it is uh, the the paradigm of Compose Web is a bit different from what compose from the Compose that we know. There are a few things that you can directly use, such as column and box and a few things other, but it is not just like writing rows and columns in a normal Compose app. You have to use div and some CSS styling based code as well. So that will be all for today. If you want me to discuss the anatomy of a Compose multi-platform project, I can just go ahead to code and show you how a Compose multi-platform's code is structured. If yes, then we can move to code, or if you guys want to ask any questions, we can move to questions.
Regarding, I have a question. I have worked with Cordova and Ionic long ago, and there was a limitation of platform-specific features. If you want to access the GPS or something, you need wrapper in the Cordova, and sometimes we didn't find good wrappers. Is there any limitation of KMM to using platform specific features? Let's assume want to use GPS or some sensor,
Well,
or is it recommended to have this code different on different platforms? Just the other simple logical things in KMM.
well, if you are building Kotlin with, okay, so the first thing is KMM does not exist any longer. We have Kotlin multi-platform KMP now. If you are building a Compose multi-platform app with Kotlin multi-platform, then it will be a good choice to write everything in the shared code base and then export the shared module as an XE framework, as a Swift frame. Pack, I, I forget the name every time. A Cocoa Port framework or anything like that. So there is nothing like um, any specific like Google Maps, or let me just show you through the code. That will be much
Yeah,
more
yeah,
easier
sure,
to
sure.
explain this. Okay, this is the app that I was showing you guys. If I go to, okay, let's just talk about the package hierarchy first. So if I go to project structure, we have Android, then have common, then we have desktop, then we have iOS. So these are different targets that I am currently targeting using Kotlin multi-platform. And if I go again to Android and go to Gradle scripts, there are different scripts like Android, common, and desktop. If I go to common, I have native Cocoa Ports plugin here. So Cocoa Ports is basically a dependency manager for iOS. You want to use any library that is iOS specific, you can use it through Cocoa Ports because it is the dependency manager for iOS. So if I go here, there is a library called YouTube iOS Player Helper. So it is an iOS specific library that is only used on iOS for playing YouTube videos. So I just write pod, then the iOS library name, just like in Cocoa Ports file on Xcode, and I can use that library then inside my iOS main. If I go here, okay, so this is the web view, and right here, as we discussed, that we can use UI kit view to display different, to use different UI kit based widgets inside our Compose multi-platform app. So I have used UI view, then added player container dot add sub view, and basically what I'm doing here is that I'm creating a YouTube player view using Kotlin from a library that is written in Objective C, and then I'm using only Kotlin to display that YouTube player that I just showed you guys on my iOS simulator, and it is working seamlessly. Similarly, you can use sensors. If I just go on top here and expand my imports. Okay, so if I write import platform dot, so there are a lot of iOS libraries that already included, like WebKit, Foundation, UIKit, Core Graphics, even ARKit, AVF Audio, AV Foundation, AV Routing. Everything that you need to build an app is already there. So and there's nothing that you want and isn't there for you, like core Bluetooth, core crypto, even audio kit, context UI, color sync, core data, core foundation. Everything is there. So any platform specific component that you want to use on iOS, it's already there. There is no limitation in Compose multi-platform with Kotlin multi-platform. And as Khurram has said, Kotlin multi-platform has solved all the limitations that a programmer might encounter during building an app. Okay, any other questions?
So, oh, I can hear myself. So basic question was that can you write Swift code directly instead of like writing that in Kotlin?
Well, there is a hacky way to do that, but currently the most supported thing that we have is UI kit at the moment. But if we see the all the blogs that JetBrains have been publishing and on Kotlin Slack, there are plans for Swift direct integration. And on the Kotlin conf, JetBrains actually said that they are moving to Swift first interoperability rather than Objective C from now on. So we can see that soon.
One more iOS related question. So recently, iOS introduced its own dependency manager, package manager, sorry, which is Swift Package Manager. Will KMP have support for that instead of Compose?
Swift Package Manager is not directly supported at the moment. There is a plugin that uh, uses Swift Package Manager to download dependencies and export them as well. But I think development on that has been paused for more than 6 to 8 months. However, if you want to export your shared module as as a Swift package through Swift and then consume it using Swift Package Manager, there is a great plugin called KMM Bridge by TouchLab, which helps you build Swift Package Manager using CI/CD on your GitHub repository, and then you can consume that from your iOS project.
Cool. Thank you.
Okay, Compose multi-platform is just some. Okay, let's clear what Compose is, rather than Compose UI. Compose was meant to be a framework that that can efficiently traverse trees. So this was the official mm, work for what Compose was built for. Compose UI used to be called Crane, and Compose was just a library to traverse tree, and they both were combined to build Compose that we know of today. So Compose runtime traverses the UI tree and then displays the whole UI that Compose UI it renders on our screen. There are some build phases that if you study that will make it more clear. But later on, Google decided to make both Compose, compiler, runtime, and all of them name as Compose. So that makes some gibberish kind of things in many people's mind. Moving on to Compose multi-platform. Compose multi-platform is just a UI framework that is used to build UIs on both iOS and Android. And again, it supports desktop and web as well. While Compose Kotlin multi-platform is a way to share business logic or code. So when you combine both Compose multi-platform and Compose UI, you get one app with shared code running on both iOS, Android, and again desktop and web as well. Kotlin multi-platform is a way to share code. Compose multi-platform is a framework to build UI that can be shared to different platforms.
Um, One more question. So, if you take this app as an example, uh, can we have like an iOS app, shared library with the business logic? Um, and can we do two-way communication, like shared library notifies the views and the views kind of notifies the other way around?
Yeah, we have actually tried that in one of our app. So we build a scanning flow with Compose Multiplatform, Swift UI, and then we have a Kotlin Multiplatform shared module used inside that app. So we have done some two-way communication. It's not perfect, but it works 70% of the times. It's doable, but I won't say it's perfect.
Okay.
Okay, for building a complex app with Compose Multi-Platform, if your app just shows some lists coming from server, then you need zero knowledge of iOS to build your app. But if it uses some platform specific things like maps, video players, downloaders, you use some story things as well, then yes, you need to know a bit or two about iOS as well. Then you can build a complete app. But if you just show some lists here and there, then you know don't need any iOS knowledge at all. Yes, uh, some knowledge like how code data works or how iOS app lifecycle works. These things are are foundation to iOS, and you need to know those. Rest can be ignored. If you are just using an app that shows lists coming from server, and you don't need to know much. But if you want to build something complex, then yes. Okay, guys, we have 5 minutes. Any questions? Yes, Faisal, I have just shown how you can use Cocoa ports to use iOS-based libraries in your shared Kotlin code. So answer is yes. Okay, folks. Any other question?
Can you share some Git repositories or some documentation other than their Compose official docs?
Uh, the press they what you see on emulator can run on your iOS devices as well. I can share my iOS device screen, or maybe I can try. Um, just give me
My
a
question
moment.
is Android. If you're using a CocoaPod library and you run it on iOS emulator, it's fine. But is this run well on Android as well?
Okay, again, this we discussed that we you need to use expect actual. For Android, you need to use Android specific library. Let me just
Got
again
it.
just
Got it.
go here and platform. Okay, so this is the YouTube player for iOS. Okay, if I go to its actual, this is the expect function that we will be using in our shared code. And if I look at its actuals, then iOS desktop and Android have their own implementations. So this is the Android implementation using Android View and Android specific YouTube player library. Similarly, if I go to desktop, here I am using a web view then that is actually a swing panel, and inside a swing panel I'm using a Java FX panel. So this is how you will be using different libraries to target different uh, platforms. So for iOS, you have to use iOS specific libraries. For Android, you have to use Android specific libraries. And for desktop and web, you have to use libraries that target those platforms. Okay, coming to Momin, your question. So there are different uh, repositories. If I forgot to add those to slides, you can check my GitHub profile. I have a few Kotlin multi-platform projects there as well. This one that I am showing you guys, it's also there. You can check Abdul Basid's repositories. Those are also in KMP, and you can for if you want to check the big daddies, then you can see John O'Reilly's repositories and Carlos Mota's repositories. These two are the big daddies of KMP. Well, I guess for me, it's debatable. It depends on what you need. But yes, Kotlin multi-platform is the future. Yeah, this JetBrains video is a good starting point that Narendra just shared. Books on KMP have, I think they are no longer valuable. Most of the things in books are already deprecated. The past year has been going very fast for KMP. Many things have deprecated in a few months, and all like the native memory manager and Kotlin 1.9 changes, the source set changes, Android target hierarchy changes, test hierarchy changes. So I don't think books are relevant for now. We do have a production app called Marcus Supplier, but it isn't for everyone. Everyone cannot see that. But I think Netflix app is built in KMP. Cash app is built in KMP. Um, Cream's driver app is built in KMP. There are a lot of apps that are built in KMP. So if you want, you can check that as well. Uh, in order to adopt KMP, you can start small, create one shared module, and try with that and check if it fits your needs. And you can then gradually move on and start creating features in your shared modules and gradually adopt KMP. Yes, monorepos plus KMP, especially if you are using Compose multi-platform. But if you don't, then and you have some code already written in Swift for iOS, some screens, some features built already, then I guess exporting the shared modules from Android to the iOS side and using um, shared code in Android as a normal module is a way to go. Okay, guys, we
I
are a
think
bit
let's conclude the session.
yeah, we are over the time, and if anyone has any last question, if not, then we can go ahead and close the session. Compose has its own life cycle, so you don't need to worry about life cycle of Android and iOS. Okay, guys, thanks everyone for joining, and that will be all for today. Hopefully, we will continue having these sessions again. We stopped having the sessions because there were a few things that we all know of. Let's just put all of that package behind and let's move on and start building our community again from the ground up. Thanks, everyone. Okay, Mohsin, do you have any question?
Kashif, I have a question if you can answer it.
Okay, guys, last 5 minutes. Just go ahead and please ask your questions.
Yeah, just one question. Can you recommend us some nice documentation or some articles other than Compose Multi-Platform official docs?
There are many. There are not many resources available at the time. You have to dig deeper. But I will share some resources in the group later on.
Okay, sure. Thanks.
No problem. Okay, guys. Any other question?
Yes, I have a question. We are making Compose production level application from 2 months. So the it's like OLX. So uh, what will be the steps I need to follow to convert that Compose application to KML?
Okay, in order to move that Compose application to KMA, you just need a shared module, shared Kotlin multi-platform module. Apply the Jetpack Compose plugin, copy and paste that code into the shared module. If you have used constraint layout, you have to convert that to uh, row, column, and box. I will suggest to go with box with constraints. It's much more easier when converting constraint layout to normal layouts. That's what I have understood from my experience, but obviously there can be other ways as well. So I think that would be the way. Just copy and paste that to shared module. But I would suggest that don't jump and do it all together. Rather go small, convert a few screens first, and then gradually do the whole migration.
Did KMM have any sort of library for materials?
Chess, Jetpack Compose, and sorry, the Compose multi-platform plugin supports Material 3.
Okay.
Okay, guys, last 2 minutes. Any questions?
Yeah, Kaushik one more question from
Okay,
my
guys,
side.
actually, I have all the libraries in the slides. I will share these slides with you in the group, so don't worry about the libraries things. Yes, Saad.
Yeah, Kaushik please recommend a tutorial about the dependencies management in the KMP application regarding the Cocoa pods that is specific to the iOS side and for the Android side, and also for the shared dependencies.
I have written an article recently. I will share that. Just remind me of your questions that need to share the links of what I need to share the links of in the group. I will share those at the earliest. I have written an article a few days ago. It has everything covered up for using UI kit views, Android views, and desktop views. It will help you get started with those things.
Okay, sure, I will remind you.
Okay, guys, last 1 minute. Okay, then I guess no more questions. Uh, Thanks everyone for joining. Let's just end it for today, and hopefully we'll meet again for these kind of sessions. And I hope you guys will also be joining again Till then, thanks everyone. Take care. Bye bye.